Hello, I'm Professor John Kelly, and this is the Weber Auto YouTube channel. As you can see behind me here, I have a 2024 Toyota Prius Prime. The Prime is the plug-in electric vehicle that Toyota sells in the Prius line. So this Prius comes with a larger battery than a typical Prius. This Prius has a battery that's rated at 13.59 kilowatt hours. It has 266.4 volts nominal and is rated at 51 amp hours. It has 72 of these prismatic cells inside of it. So I've removed the battery from the vehicle, completely disassembled it, and have an empty housing sitting right here. And I'm going to show you, as I reassemble this battery, all the individual pieces that make up this battery and discuss how it works and so on. This battery being under the vehicle for the first time on a Prius is a refrigerated battery rather than an air-cooled battery. So typically in the past, Prius batteries have been air-cooled behind the back seat, air-cooled and heated, behind the back seat or under the rear seat cushion. But this one is refrigerated, much like some BMW batteries. So let's get started looking at the individual pieces of the Prius Prime battery. Okay, as you can see here, I have an empty housing. It does have a gasket on it that I've left on. It is a reusable gasket, and it has metal inserts in it. This housing has some little kind of foam pieces in it called pushers that give it a little bit of a spring load to some of the refrigerant lines where they contact the battery to remove heat energy from the battery. But in the very bottom of this housing, as you can see here, being empty, they have some parts that, and I don't know what to call them other than a heat reflector or an insulator. But let me show you this part. It's very delicate. It's just little tiny, real thin insulator. It's the same kind of a copper-looking coating on each side. It's very, very thin. And I'm just going to call it a heat shield. But in the Toyota service information, they don't give it a name at all. They don't even acknowledge that it's there. But it is certainly there. And there's more of this material in between the three stacks of battery cells that we'll take a look at here in a little bit. So let me set these heat shields in the bottom of the housing, as you can see here. Okay, then the next thing that I wanted to see on this battery that is also on the first generation Toyota Prius Prime that here in the United States came out in 2017. Now I realize there was a plug-in Prius prior to that, but the Prius Prime from 2017 through 2022 looks like the one in this photo that I have over here on the bench in my shop that I use in my classes. And I shot a video on that battery when I took it apart and put it back together, and it has a heater, a battery heater inside of it. Well, this one has a battery heater also. This is a low voltage electric heater. It runs off the 12 volt system. It has a heater relay, and there's a left section and a right section that are individually controlled. I'm going to set that down in here on top of the heat shield. Guess it would help if I put it in the right way. Has some little alignment studs over here to hold it in place. This heater, there's no description at all other than there's a heater in the Toyota service information. But if you go back and look at the first generation Prius Prime, the heater that looks just like this and is low voltage also is only used to keep the electrolyte from freezing in the individual cells of the battery. So this isn't a heater. This doesn't appear to be. I could be wrong. If any of you know, let me know in the comments. But this appears to be just a heater that comes on at really cold temperature, turns off at a really cold temperature also, but its job is to keep the electrolyte from freezing in the cells. Each side, the left and right side, do have their own thermistor. There's a thermistor 0 and a thermistor 1, and then just a 2-wire power and ground 12-volt circuit, and a giant series circuit that's on each side. The heater elements in the previous version of the Prius Prime were rated for right around 100 watt is all. So there's not a lot of heat energy being put off there. I mean, that 100 watts is still a good amount of heat energy, but anyway, there's no description. I'm not, as I said before, I really don't know at what temperature this turns on and what temperature it turns off. I just assume that it's like the previous one. Okay, the next part we're going to look at, Toyota calls the cooler sheet. But this is the aluminum channels that the refrigerant goes through. And as you can see here, I've got 3 channels. We have an inlet over here on this side, and then over here we have an outlet on the other side with a thermistor measuring the temperature of the refrigerant. So on the, well, let me set this down in here. This sits on those same alignment dowels. Okay. All right. So the refrigerant is going to come in over here, come over and go through this first channel all the way to the other side, and then come to the center channel, go all the way to the other side, and then down to the last channel where it comes and goes back out on this pipe over here. So there's some blocked off passages that force the refrigerant to flow in a certain direction. There are also additional parts to the refrigerant system. There's what Toyota calls a magnet valve. It's a precision stepper motor. There's a pressure sensor that it looks at, and an additional temperature sensor. So we have an inlet and an outlet temperature and a variable orifice that we can control with a precision stepper motor to control the flow and temperature of the refrigerant going to the cell stacks. But we won't put those in until after we get the cell stacks installed. So the next thing we need to look at is the cell stacks. I have one cell right here, and I've measured it. This is from the first generation Prius Prime. It's the exact same dimensions as the cells in this battery's cell stack. It's the same looking housing. The terminals are a little bit different on the top. It does have the same vent in the middle if it overheats, and we've got a positive and a negative terminal right here. This is called a prismatic cell, and it has this aluminum housing. Just a little tiny spot right here in the middle of this cell is what sits on these traction battery cooler sheets. So all we are getting as far as surface area contact is maybe an inch, 25, 26 millimeters square of surface area for heat energy transfer from the cell to the channel that the refrigerant's flowing through. So it's not a great big area, which surprised me. I mean, it's better than nothing. So we have 72 of these cells in this battery. There are 3 stacks of 24. So we just stack them on top of each other, 24 cells in each stack. And I want to show you a cell stack next. Okay, on this cart right behind me here, I have 3 stacks of cells. Here's one stack right here. Here's the center stack, and here is another stack. If I turn these sideways, you can see the length of the stack of cells. And as I showed you this cell before, we just have an individual cell, and these are all in series with each other. We have 12 of them on this side of this white center divider, and then 12 more on the other side. So as I mentioned before, this is the exact same dimensions, and we just have 24 of them stacked up in this big cell stack here. This cell stack is compressed from the ends, and then it is riveted together with some big straps. There's 4 straps, 2 on the top, 2 on the bottom, that hold everything in place. Now, if I turn this around, let's take a look at the bottom of one of these. Oh, the voltage on these stacks would be 1/3 of our battery voltage. So nominal, we have 266 volts. So this would be 1/3 of that. On these cells right here are charged a little higher than the nominal 3.7 volts. And I have roughly 90 volts from one side to the other, which would give us 270 volts for the 3 of them put together. But if I tip this cell stack on its side, you can now see the bottom of all of the cells where it makes contact with the cooler sheet that the refrigerant runs through. And there's some little conductive, thermally conductive pads there to help transfer the heat energy from there. But that's, you can see kind of some witness marks from the adhesive of the or the sticky portion of the thermal interface material. It uses about, I'd say, 3/4 of that open area there for heat transfer. So that's the cooling of the battery. As far as I'm aware, they don't heat this battery with the refrigerant using the heat pump system. This Prius does have a heat pump system, but if they are heating the battery using the heat pump system, I haven't figured out how they're doing it. So it could be that, but as I mentioned before, that the heater that's in it does not appear to be for heating the battery for maximum efficiency. It's just there for electrolyte freezing or preventing the electrolyte from freezing. All right, now let's look at this other cell here, or stack of cells, cell stack. I have removed, or I will remove, all of the upper covers that are on this cell stack so that we can see the connections from cell to cell in the battery stack itself. So let me slide this over and tip it. Here we go. Okay, so we have right here on the end, we have the two terminals. There they are, 2 terminals right there. And this would be either positive or negative, I don't know, down to another cell, and then a bus bar to put it in series with the next cell, and then back and forth, up and down, serpentine, just like on any other previous Prius battery. And then we have a bus bar that's longer than the others that connects this side to the other side right here and continues all the way until we have the end post over there. So one of these ends will be positive, the other will be negative. And then we put these 3 cell stacks in series with each other to get the overall 266.4 volts nominal voltage. There are also all these little tiny wires that you see here. We have 5 temperature sensors. There's one right here with these 2 green wires, one right here with 2 black wires, and there's 2 white wires, 2 blue and 2 pink. You can see all the other wires. We have cell voltage sensing circuits. So the battery cell monitoring computer has to monitor the individual cell voltages of each cell, just as if you put a voltmeter across each one the entire time that you're operating the vehicle, and even when you're not operating the vehicle, actually. So each of these cells is monitored for voltage. There are 5 temperature sensors in here. 1 there, 2, 3, 4, and 5. Each cell stack has 5 temperature sensors. Okay, and each cell stack is basically the same, other than which end has the positive and the negative on it for when we put it back together and connect them in series. These orange connectors, the small orange connectors on the end over here, are the cell monitoring and temperature sensing circuits that plug into the computer that monitors those. I wanted to show you one more thing though. On this center stack of cells, I'm going to zoom in. I want you to look at the heat shield that's on this one also. It's that same copper colored material. Looks like it's sprayed on, and there's a shield on the outside, there's a shield on the inside, and so I think that the purpose of that shield is to keep the heat energy from each of the cell stacks from impacting the heat energy of the other cell stacks. So they're kind of thermally insulated from each other. Okay, so the next thing I need to do then is to put these cell stacks back in the battery. So let me get those put in and we'll continue on. Okay, I've got 2 of the 3 cell stacks installed, and I was about to install the third one when I realized that I had not installed the wire harness brackets and harness that need to go in before that cell stack is installed. Otherwise you can't get the bolts into the brackets. So I'm going to install those wire harnesses next. So there's a bracket for the electrical connection that goes from the high voltage battery up to the inverter under the hood that I need to install. So let me get that in here. All right, there's another bracket that is for the plug-in charge connection. When you plug in the charge cord to the side of the vehicle and it's converted from AC to DC, that current comes in on this connector. And so let me get it installed here. All right, next we have the low voltage harness connection that comes in and connects to a whole bunch of stuff inside the battery. And so let's get that installed. Oh, it also has the refrigerant pass-through. The high and low pressure lines come in right here and connect to the inside refrigerant tubes through that connection. So we'll route all these through the hole here. Okay, I think we're ready to bring in that other stack. All right, no pinched wires. Looks good. Okay, now with all 3 cell stacks installed, there are some additional brackets that need to go on over the cell stack brackets, and those brackets are used for holding up a plate that goes over the top of these cell stacks that all the computers and relays and everything else connect to, and also the refrigerant, the additional refrigerant lines that I mentioned. So we've got these brackets. There's 2 identical ones that just fit down over the studs that hold the cell stacks in place. There we go. And then we've got the nuts that hold those down. Now I need to look up the torque spec. Okay, I just read something in the Toyota service information that I missed before, and that is that if you're replacing one of these stacks, that you also have to replace the cooler sheet, the refrigerant line that I showed you, that the refrigerant goes through. They say it's not reusable, but I'm going to reuse it anyway here for my class purposes, and we'll just have to keep an eye on it, see how things go. But I imagine it's because of the spongy material that they call pressers that make the contact between that surface area at the bottom of each cell and the refrigerant pipe, the flat refrigerant tubing that the refrigerant goes through. So that's interesting, but not surprising. All right, so we've got 8 pound-feet here. Oh, looks like my batteries are dead, which is 10.8 Newton meters. 16.3 Newton meters on all of those studs, the nuts on those studs and the brackets that hold down the outer edges of the cell stacks. Okay, so the stacks are firmly bolted down. Now we're going to connect the stacks in series with each other. This stack over here on this end is overall battery positive, and so we would have negative on this end of the stack. So we've got this orange cable that will plug into the positive of the center stack, and then it would have a negative over here on this side that plugs in with this cable to the positive of the first stack over there, and then overall battery negative is over here, which is on the side with the manual service disconnect lever, or the service plug grip, as Toyota calls it. It's a rather large one right here, and it's under the back seat lower cushion. It has a large fuse in it. I forget what size. I have an additional refrigerant pipe here that has the precision stepper motor in it to control a variable orifice. Toyota calls it a magnet valve, the number 1 magnet valve. So we have refrigerant coming into this variable orifice, and then it controls the volume going over and through that cooling plate. So there are O-rings on this pipe that have to be replaced. So I purchased new O-rings. I better get those installed before I put this on. I don't want to have to take this out of the car again. I don't want any leaks. There's 4 of them we have to change on the inside of the battery, and then there's 2 different size ones on the outside of the battery where the refrigerant pipes connect from the air conditioning system to the battery itself. All right, there's our second one. All right, so here's the new O-rings from Toyota. Part number 90991458 for the small ones. All right, so that's one of the two pipes we need to install. The other one is a little short one that has a pressure sensor attached to it with those same size O-rings. So you can see this has a 3-wire refrigerant pressure sensor attached to that pipe. Here comes our refrigerant pipe. All right, there's 2 bolts and a nut that hold that pipe in place. And we've got a nut that holds the magnet valve to the bracket over here. And we've got the other pipe right here with the sensor. Okay, at this point, after installing those refrigerant lines, they want us to do a leak check of the system, and they have some special adapters to connect to the front of that, which I don't have and cannot purchase. There's a special service tool kit for this battery, and I've called Toyota Special Service Tools, and they do not have any for sale, and they have no idea when any will be available for sale. So I am hoping that I just don't have a leak, because I don't have a way to check it. So the next thing is to install the bracket, this plate that goes on top. Toyota calls it the number 10 bracket. It's a great big one. So let me bring that in and let's get that installed. Okay, here's the number 10 bracket that's going to go on top of all of this. Let me just double check, make sure I don't have any wires or anything else laying on top. Looks good, so let's bring this in, and there's some alignment rods. There we go. Some studs, alignment dowels right here, and then some nuts that hold it in place. So we've got 1, 2, 3, 4, 5, 6 nuts that hold it in. These little nuts are torqued to 66 inch-pounds, just a little over 5 foot-pounds. Now, let me check the other side. Make sure we've got wire harnesses out of the way. Looks like it. So there's one bracket that isn't called for at all in the Toyota service information, but it's here. And I couldn't figure out where it went for quite a while, and it's a good thing I took photographs when I disassembled it, because it goes over here. So actually I better get the outer perimeter gasket installed. Got to be real careful with this gasket with the metal inserts, because they like to fall out. I've lost one on the floor over there already, I can see. And we don't want them falling down inside of this battery housing. All right, now this other bracket, this strange one I told you about, I can install it. So it comes in. Goes right here. Not sure why it's there, what it's doing, but that's where it goes. Okay. All right, now we can bring in a couple other brackets and harnesses, computers. All right, so this box right here is the battery junction box. It has the negative and positive contactors in it and a current sensor. But Toyota doesn't use a pre-charge contactor anymore in the Prius Prime, and I suspect in the other Toyota products also. They've done what Tesla has done, and that is they use the DC to DC converter backwards. So it's a bidirectional DC to DC converter to pre-charge the high voltage system, so that when you close the contactors, it has the same voltage on both sides of the contactors anyway, and there won't be any inrush of current that could cause damage. So there's some empty slots here. These empty slots right here are for a solar roof. You could buy a solar roof option, which I thought that I ordered, but it didn't come that way, that has its own contactors to charge the high voltage battery off of a single solar panel, and it would take quite a while to do that. But this junction box is going to go on this number 10 bracket next here. So let's see if I can figure out. Looks like it goes this way. Yeah, just like that. And has nuts that hold it down. But I'm going to pre-position parts on here first before we bolt anything down. Now we have the two outlet wires from the contactors, the positive and negative contactors, that go to the electrical connector on the front of the battery that goes up to the inverter under the hood here, and they connect right here. And then there's a bracket right there. And another bracket right here. And then this connector goes down in this housing over there. All right. Now we've got a couple more things to put on here. We have the battery ECU assembly, the battery computer, and it sits right here. And then we have the battery voltage sensing computer that measures all of these cell voltages off of these orange wires over here. And it sits right here. And all these orange wires plug into that. Then we have the relay for that heater that we talked about. And it goes right there. And then we have another connection, the connection to overall battery positive, I believe. Yes. That plugs into our junction box and into our number 3 battery cells, or the cell stack. And looks like I've got a couple more wires for charging, the plug-in charging. And they come in, plug in right here. Just like that. So now our overall battery negative connection goes to the top of this bracket and then plugs in over here. That's all the components that go on this number 10 battery plate. But we have the wire harness that has to, wire harnesses that have to come in and plug in here also. So there's a whole bunch of nuts I need to install and wire harness connections I need to make here. So I will get those connected and be right back with you. Okay, I'm ready to put the cover on, but before I do, I want to just do a quick overview of all the parts that are in this battery. So we've seen the heat shield in the bottom, that kind of copper colored heat shield in the bottom of the housing. We've seen the battery heater, resistive type heater. We've seen the battery cooling channels for the refrigerant that goes through there. Then we had the 3 stacks of 24 cells each. Each of those stacks had voltage sensing lines that came out on this. Let's see, this would be the driver's side of the vehicle, the right-hand side here in the United States. Battery voltage sensing computer, and then it has a connection that goes over to the battery ECU, the overall battery computer. And then we have our battery heater relay right here. We have our junction box with our positive contactor, our negative contactor, our overall battery positive connection from cell stack number 3, and our overall negative connection from cell stack number 1. But the negative connection comes through our manual service disconnect lever connector right here. So this manual service disconnect lever with a fuse in it, when we get it back up in the car, is going to plug in right here. And when it does that, that will connect these 2 wires together, the negative cable together, to where there would be full battery system voltage, negative here and positive here. And then these 2 contactors connect these 2 cables to these 2 cables that go out to the inverter, out along the bottom of the car and up to the inverter underneath the hood. We have these 2 little orange wires here that are plug-in wires for plug-in charging. So when you plug your charge cable into the side of the car, I think it's 16 amps maximum is all this battery can handle. So that current comes in here after it's converted from AC to DC. Let's see, what else do we have? We have what looks like some sort of a splice assembly right here. It's got several white wires with black stripes, which I believe is just a ground splice connection. And then we have a temperature sensor for the refrigerant pressure on the inlet, and another temperature sensor for the outlet over there, a pressure sensor for the refrigerant pressure, and then as Toyota calls it, magnet valve, the stepper motor right here to control the refrigerant flow. And then that, in combination with the compressor and the other valves, controls the overall pressure. As far as the connectors on the front of this battery, I have another video where I showed you what those connectors are when I checked the low voltage charging system on this car. But we've got the 2 wires that go to the inverter. We have 2 wires that come from our onboard charge module that when we plug in the charge cable. We have a black electrical connector, which is all of our low voltage harness connections that go to these harnesses that have black tape or black conduit around the outside of them. There's a pass-through connector for the high and low side refrigerant pressure lines. So it's an aluminum block pass-through. So there's 4 connections on the front of the battery: the refrigerant, the low voltage, the high voltage to the inverter, and the high voltage from the onboard charge module. All right, well, I'm ready to put the cover on and get that bolted down and put back in the car. So I just wanted to, and I've been wanting to for quite a long time, take this battery out of the car, take it apart, see what's inside of it, and now I'm just going to put it back in the car. When it goes in, we have to recharge the refrigerant system, of course. There is no coolant that flows through here. It's just refrigerant. So we'll have to go through a big, long evacuation and recharge process. So I'm not going to show you all that. I'll just get it put in the vehicle and be done with it. On disassembly, there was a special scan tool procedure, a special function, what does Toyota call it, where you can command something to happen. But You have to use the scan tool to command the heat pump system, solenoids, and precision stepper motors to open to allow the refrigerant to be removed without having any trapped somewhere behind a solenoid or a stepper motor. Okay, after I installed the battery cover, I realized I forgot to show you some interesting things on the top of the battery. There are two things of interest. One is right here. There's a little black vent. It's called a Gore-Tex vent or a Gore vent, and almost every high voltage battery has it. It allows for differences in atmospheric pressure changes. It also allows air as it heats inside the battery to expand and come out. So there's a metal cover that bolts over that sort of as a protector. But the other thing that I thought was very interesting is there's this round cap that goes right here, and I unbolted it, and it has this little door. It's a spring-loaded door, and it shows right on it a hand with a line through it saying "Don't touch," but I got to touch. So I push on it, and it's a spring-loaded door. So the spring-loaded door, I assume, is in case there's some sort of a thermal runaway event in the battery. This would allow hot gases to escape quickly rather than just through that little tiny Gore-Tex vent right there. So it's a very stiff spring. This has a cover over the top of it, I'm sure, to protect it from dirt and weather and whatever it may be. But this plugs this hole over here and has this cover on top of it. So, and while we're here, here's the battery cover installed, just so you can see. So now I'm going to put it in the car and get the car working again. Thanks again. Have a good day.